warahmatullahi wabarakatuh, and a very good day to everyone. So we move on to the next chapter, which is random variables. so uh, indirectly, I believe that you have done or you are familiar with what is random variables already, especially when you deal with your uh, experimental layout, right? So uh, what is what is random variable? In order to analyze random experiment, we usually focus on some numerical aspects of the experiment. A random variable is a variable that assumes numerical values associated with the random outcome of an experiment, where one and only one numerical value is assigned to each sample point. Okay, let's take a look at this futsal match.
Tidied up, highlights from the game, and Iran started with a wonderful goal here, scored by Zareh. What a lovely finish it was. Initially it was Golami with a superb turn and great interchange with Etadadi. That was Iran 1 up. The equaliser though would come via the penalty spot. Referee spotting a handball and showing a red card to Golami. And the penalty dispatched by who else but Farahia Rizwan. 1-1 going into half-time. In the second half, Zareh would be very influential, setting up that goal for Zarinrad. Cool as you like finish. That was nearly another. Again, Zareh causing all kinds of mayhem. The ball across, though, well gathered that time by Noraziza. Another chance, and that one off the post from Mesami. Malaysia at 6s and 7s in defence. And that was the closest Fatin Azmi has come tonight to a goal. This would prove crucial. The goal from the kick in to save Malaysia from defeat. Chance here that cannons off the post, and by that time the full-time klaxon had already gone, so Izati's goal did not count. Good awareness though to tuck the rebound away. Full time then, 4-2, 10 shots on target for Iran, 8 shots for Malaysia.
Okay, even though you might think that this is just a football match and it does not cut and it does not have something to do with the engineering statistic, but actually, as the name also suggests, so this is the full-time statistic. So this is the application in a real world. For example, right? If let's say these are the statistic that we are going to be interested with, the variable, for example, the shots on the number of goal that they have. Iran 2, Malaysia, Iran 4, Malaysia 2, shots on target, shots off target, possession, corners, yellow and red cards. Okay, so these are the variables, random variables that we are interested to know in this futsal match. If we consider an entire soccer match as a random experiment, then each of these numerical results gives some information about the outcome of the random experiment. A random variable is a real valued variable whose value is determined by an underlying random experiment. Okay, for example, Ahmad tossed a coin 5 times. So you can imagine that this is a random experiment, and the sample space can be written as head or tail. So these are the probability that is going to get tail, 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 head, or and the list goes on until you can get all the probability of the from the random experiment. Note that here the sample space S has 2 to the power of 5 equals to 32 elements. Suppose that in this experiment we are interested in number of hits. We can define a random variable xx whose value is the number of observed hits. The value of xx will be 1 of 0, 1, 2, 3, 4, or 5 depending on the outcome of the random experiment, because there are 5 times that he tossed the coins. So in essence, a random variable is a real valued function that assigns a numerical value to each possible outcome of the random experiment. For example, a random variable x defined above assigns the value 0, 0 to the outcome, t, the value 2 to the outcome, th, and so on. Hence, the random variable x is a function of the sample space s equals to t, uh, and the list goes on until h to the real numbers. For this particular variable, the values are always integers between 0 and 5, because it tested like 5 times. Okay, a random variable is a function from the sample space to the real numbers, so s to r. Okay, basically, random variable can be divided or categorized into two types of random variable. A discrete random variable can assume a countable number of values. For example, number of steps to the top of the Eiffel Tower. Remember that a set A is countable if either A is a finite set such as 1, 2, 3, 4, or it can be put 1 to 1 correspondence with natural numbers. In this case, the set is said to be countably infinite. A discrete number, if a sample space contains a finite number of possibility or an unending sequence with as many elements as there are whole numbers, it is called a discrete sample space. In the meantime, a continuous random variable can assume any value along a given interval of a number line. The time theory stay at the top when he or she gets there. If a sample space contains an infinite number of possibilities equal to the number of points on a line segment, it is called a continuous sample space. Mean to say that if, let's say, you want to make it in a simplified form, it is a measured data. Okay, for example, we can see here the two types of random variable. The discrete random variable, for example, the number of sales in the business, number of calls in the call center, shares of stock in the stock exchange, and people in line for the EPF this withdrawal counter, and the mistake per page, for example, for your proposal. And in the meantime, for the continuous random variable, it can be the length, the depth, volume, time, and weight. So we need to say that it is a measured data. We need to say that a continuous that lies in the set of data. So because okay, this is the different arrangement, yeah. So I think you can refer to your group for your proposal. So divide yourself according to the group in the proposal, and then once you from your proposal, this is the addition from your proposal. This is the the kind of element if you want to add on to your proposal, which is to prepare your proposal in the form of the infographic. Because basically, I believe that you have already all the data here. I mean to say all the objective, background study, procedures, and conclusion, or maybe assumption. So you can put assumption here. And I mean to say that in this infographic, you just have to include variables, because I believe that you already have 1, 2, 3, and 5, right? So you can include the variables and make it in the form of infographic, and you can submit the assignment, which is falls under the proposal next week. Okay, all right. So because I have to go through all your proposal by this week, because this Thursday we can have the test one, Uh, okay, so I think this is for your random variable, and we will continue in the next part. I will upload later on. Uh, okay, so just a little bit on your test. On your test, of course, I mentioned in the group that there are going to be two questions. The first question going to be on the statistic, how you want to draw the graph. So of course, you have to know how to find the properties of the graph. That's all the hint I can give. The properties of the graph, and of course, whilst like if you want to draw the graph, of course it's going to be quite time consuming. So make sure that you make it really fast because you only have 1 hour, right? And then, but I believe you can finish on time because yeah, it's not that difficult because it's a test one, right? So the second question is going to be on probability and some hands-on applications. All right, so I think that's all from me today. So all the best for your test this Thursday, and I will go through your proposal. And once I approve your proposal, you can start doing your experiment. Sorry, not experiment. You can start doing your uh, yeah, your project. Yeah. Okay. All right. Thank you. All the best.